So the question here is we need to guess the direction of air near the cold can. Two things can be observed here looking on the slide. So first is it's a cold drink can and its surface must be really cold. And another is it's a hot sunny day. A hot sunny day means the air near the cold can would be really hot. The first thing that comes to your mind, like what would be the direction of air near the cold can? Let's have some guess. So, is this the direction that the hot air is going from down, from bottom to top? Is it correct? Think for some time. No, it's not correct because you need to think about the density also of the air. What changes will happen for hot air and cold air? So, what is happening actually? The hot air near the cold can is cooling itself, and so the heat transfer is taking place. So it's like this: a hot air is cooling, the hot air is cooling near the cold drink can, and it becomes cold, and that is why the cold air will be at the bottom. Why cold air at the bottom and hot warm air at the top? We know that the temperature is inversely proportional to the density. So density is inversely proportional to temperature, I mean. So density will reduce with the increase in temperature. The hot warm air has lower density than the cold air, and so it should be at the top, whereas the cold air would be weighing heavy. It would be heavier than the warm air. So it goes at the bottom. So this is the direction of the air near the cold drink can. And this is the heat transfer that takes place due to the natural convection. Because of natural convection, the heat transfer rate is really high. Imagine this must be in a case of conduction. So while if conduction was there instead of convection, the heat transfer rate would be really low. So that's all about the question of this cold drink can. Drink it before it gets hot. Thank you.